so awesome to be here. Thank you so much for having me. It's actually my first time at Creative Mornings, and I can't tell you how excited I am to know that this is actually a thing. The most exciting times of my life have all started with discovering a new community. Boarding school, studying abroad, architecture school, campus ministry, founding a startup with my next door neighbor. For me, it always starts with this, an encounter that stirs something that was dormant before. Rebecca Solnit called it the open door, glimpsing the unfamiliar over the threshold and realizing that you belong on the other side. And that's really what I want to talk about this morning. I've actually daydreamed about giving this talk since I was in design school, where I learned the art of presentation titles. So even though you can't see it, I call this talk Something as Something Else. I can't tell you how many lectures had this title, but as much as I laugh at it now, it's really the best way I can sum up the stories that I'm going to share with you this morning. Our biggest breakthroughs always seem to happen by accident, and progress would take us by surprise, whether we knew it or not. In August 2016, Shop Architects out of New York City approached us about 3D printing a pavilion for Design Miami. It's the biggest thing we've been approached with to date. It's designed by a Starchitect class firm, and it's going right at the front door at one of the biggest art shows in the world. For us, as a startup and as recovering architects, this is a godsend. It's the big break that we've been hoping for since day one. Now, at this point, we're still a small shop, 6 people and one really big robot. Design Miami is scheduled for the end of November. That gives us 4 months to go from concept design all the way to the installation. Now, we'd completed our last project in 4 months, but we worked double shift 7 days a week to get it done. And in the end, we burned a lot of money that we hadn't made back, and we were on track to run completely out of funding by September. So the stakes are about as high as they can possibly get. In 4 months, we have to triple our staff. We have to build 2 new printing robots, a 2-month process. We have to completely rewrite the printing algorithms, and we have to build a structure 10 times larger than the previous project in the same amount of time.
So you're telling me there's a chance?
Yeah! At this point, we're also counting on winning a research grant come September, the same month we run out of money. If we build the project, it will be the largest 3D printed structure ever created. We'll get a foot in the door with the biggest client we've ever had, and our company will be in the spotlight at one of the wealthiest design events on the planet. But if we fall short, we'll owe damages to the client, ruin our reputation with a top-tier firm, and burn what may be the last of our funding. We're all thinking the same thing to ourselves. There's no way we can pull this off. But in spite of everything, we knew we had to say yes. The first thing you need to know about Branch Technology is that we didn't work our way up to the crazy stuff. We started with the crazy stuff. Black Boy, the founder of Branch, was my next door neighbor for 11 years in my hometown of Montgomery, Alabama. He'd previously been a practicing architect for 15 years, and I'd worked as a summer intern at his firm. During Christmas break, my 3rd year of architecture school, Platt shared his idea for a new kind of 3D printing that could be used to construct entire buildings. Well, when I saw his first sketch, I had absolutely no idea what he was talking about, just like you probably have no idea what I'm talking about right now. But as the conversation went on, we both got more and more excited, and I knew that this wasn't just brainstorming. Platt later came across a Kickstarter campaign for a 3D printing pen called the 3Doodler. Have you guys seen that? It was able to melt and solidify plastic in midair, allowing you to literally draw in 3D. He ordered one immediately and even ordered a Chinese-made knockoff that happened to ship about 2 months sooner. And he began drawing truss-like structures and found that with only a few ounces of material, he could support stacks of architecture books he had laying around the house. The idea was that you could print this structure at a much larger scale and in virtually any shape. Then you could fill it with other materials like concrete and make the walls, floors, and roof of a building. After drawing and testing probably about 5 of these structures, Platt left his senior partnership at his firm and started working full-time on 3D printing ideas. And after 2 months of working in Platt's spare bedroom as an intern, I left architecture school and joined him. We had no background in starting a business, fundraising, programming, robotics, material science, or mechanical engineering. But what we lacked in these somewhat critical skill sets, we made up for with ambition.
See? Right there, that's an amazing skill. Now, what am I good at? I can shred on the drums, and I'm a marketing whiz. And put all that together, what do you get?
I don't know, a band?
No, that's been done before, even better. We are going to start an international entertainment company, the biggest and the best. And we're going to call it Prestige Worldwide.
Sounds so cool.
Now, before this, I had planned to take a few years before graduate school to learn woodworking, welding, and other crafts that I thought would help my design career. Instead, I ended up with Platt writing algorithms for a robot arm with a 3-doodler strapped to it. I definitely did not see that coming. After a few months of traveling, tinkering, and typing, we had about $250,000 in funding, a robot arm on loan, a way to generate robot code, a patent application, and a research grant. We worked long days in a tiny beige office with no windows. We ran hundreds of tests, and the machine heated the whole office to about 80 degrees. We were programming the motions into the robot, but still controlling all the print systems with analog knobs. You had to be an octopus to run this machine. We ran a tiny air compressor almost constantly and went home every day with ears ringing, smelling like burnt plastic. But it was the stench of progress, and it wasn't long before we were going to have to think bigger. In April 2015, we were invited to GigTank, the 3-month accelerator program here in Chattanooga that had chosen to make 3D printing a focus among its startups. And in Chattanooga, we found an enthusiasm and a level of support that we'd never encountered before. And so in May, we decided that it was time to move. Now, a few months prior to moving to Chattanooga, we had placed an order for a new, much bigger robot arm from KUKA. The system was a 10-foot arm that could move freely on a 30-foot track, creating a build volume that was 50 feet long, 10 feet wide, and 8 feet high. All told, it would be the largest freeform 3D printer in the world. We found space in the Business Development Center on the North Shore, hired Tony DeSanto, an engineer in Chattanooga, to design and integrate the robot as a 3D printer. The robot and track were scheduled to be delivered in late April, which would have given us time to set up the whole print system and prototype our first large-scale structures before GigTank's demo day finale at the end of July. April and May came, but the robot did not. We didn't end up getting it until late June, at which point all the other components of the system were behind schedule as well. We had a month to get this thing running from a standstill. By the third week of July, after many hours of intense R&D, which definitely did not involve playing with a 10-foot robot arm, we were finally ready to build our first big structure for demo day. As we entered the final push, I stayed late into the night to debug the print program that we were planning to run, and arrived that Friday morning to find Platt and Tony standing on either side of the robot looking absolutely devastated. I looked at the printer itself and saw that the nozzle, the single most important piece of the whole system, which you can't see here, where all of the freeform magic happens, was completely bent shut at the tip. The robot had been programmed, probably by me, at the wrong height, and slammed directly into the floor, nozzle first. Now, the nozzle itself is 3D printed in aluminum. It costs about $2,000 and it takes 2 weeks to make. And we'd just broken it with 4 days before our first public debut. We found ourselves in the worst possible position, not unlike other startups before a big day.
You're not hearing me. It's not going to say hello.
Fix it.
Fix it?
Yeah.
In 40 minutes?
Fix it.
I can't.
Who's the person who can?
I'm the person who can, and I can't.
It's Apple, by the way. With time quickly running out, we did the only thing we could think of. We cut off the bent tip with a hacksaw. And guess what? The machine printed twice as fast as before, and it doubled the strength of the product. You can't make this stuff up. It's especially funny when you consider our company's slogan, build like nature. All the forms in biology that had served as an inspiration for us, the beautiful, the intricate, the efficient, were the product of one simple mechanism, the accident. Genes get copied wrong, continents split apart, an asteroid slams into the planet and the environment changes in the blink of an eye. Advantages become handicaps. The rules change. But it's in that moment that you taste a rare form of freedom. Where before you had no reason to adapt, to grow, now you have no reason not to. When you lose the fear of making mistakes, you discover the things that you could never have planned for. We went on to debut one of the largest 3D printed structures ever created at Demo Day, winning the Investor's Choice Award. Within a few weeks, our work was being hailed by publications like Architect and Inc. magazines as one of the year's most promising new technologies. Over the next year, we tried replacing the broken nozzle with newer designs, but always ended up returning to the original. So this was it. We'd proved the concept. We had the largest freeform 3D printer in the world, and it was working better than ever. Platt ended his pitch at Gig Tank with our tagline in the form of a question. What would you create if you could build like nature? Now, you would think that the team of designers who created this process would have an endless list of projects, and we certainly had our ideas. But the truth is, we'd spent so much time creating the process, we hadn't had the time to design a masterpiece we could create with it. What we needed was a design that people could picture in their own lives, a home. We wanted to tap the unrealized potential of digital design that so many had explored since the advent of CAD, but that existing technologies simply couldn't bring to life. And so in the spring of 2016, we decided to host an online competition. We were going to invite the world to design the first ever freeform 3D printed home. Now, we'd had a lot of great press on the heels of Gig Tank, but we were still only a team of 4 people in Tennessee, looking to make a place in a multi-trillion-dollar global industry. We had no idea what kind of response we were going to get from the jungle of the internet. We needed to advance the technology a great deal to make printing more complex designs a reality. So we hired Chattanooga's own Bruce Hilbert to add some major league brain power to the technical team. We were also completely new to internet media and marketing. We needed to get the big names in technology and architecture to reach the talent we were looking for. For that, we hired Melody Rees, who had previously designed high-profile projects at Gensler, the largest architecture firm in the world. We got the word out to top-tier firms and websites that this competition was going to change the game. We asked designers to submit their wildest ideas and open up the competition for people around the world to vote and help us pick the winner. We would never have believed we'd get the response that came flooding in. Over 19,000 people from 93 countries participated. Designers submitted some of the wildest and most imaginative designs we've ever seen. Choosing just one of these projects was nearly impossible. Any one of them could have been a masterpiece beyond our wildest dreams. But one design finally took hold of our imagination and wouldn't let go. You can see a little bit of the curves. It's called Curve Appeal. It was designed by WATG architects in Chicago, and we're going to start building it right here in Chattanooga this year. We could have tried to do it all ourselves. We could have drawn within the boundaries of what our technology could create at that time. Instead, we invited designers to break all the rules, even our own, and push beyond what even we imagined was possible. And so the thing that we're most proud of isn't something that we've created. It's what we've empowered other people to create. For us, this isn't just a job, it's a calling. It's a purpose that drives us through all the challenges, and it's the reason why we have to say yes. So now we come back to August of 2016, facing the biggest project of our lives, when Shop presented us with an extraordinary design and an extraordinary opportunity. This was the moment where we would decide if we really believed that we could do what we set out to do. For me, and for I think my teammates also, this project wasn't about the limelight. It wasn't about the design, or the money we might make, or the people we might impress. It wasn't about what we felt equipped to do. It was about what we felt called to do. It was a chance to take a leap of faith. For every challenge we saw going in, there were 10 more thrown at us every week for months. But with those challenges came breakthroughs that reinvented nearly every aspect of our work. In the midst of the most challenging times of our lives, we experienced what I can only describe as an outpouring of grace. In September, we were awarded a $750,000 research grant to fund the developments that will help us build curve appeal and ultimately complete buildings of all kinds. Platt and I were invited to Los Angeles to receive Hanley Wood's top design award for housing, innovation, vision, economics at the Hive Conference, taking the stage next to Tesla and other incredible companies. And when November came, we shipped 6 semi-trailers of parts to Florida and installed the world's largest 3D printed pavilions at Design Miami. Since November, life at Branch hasn't slowed down for a moment. We've taken on new and exciting projects like developing 3D printed habitats for NASA's planned space station on the moon, currently Tony's baby. Within 4 weeks of hiring our new head of sales, David Fuhrer, we took in over $2 million of project proposals and are now looking to more than double our team in manufacturing operations by the end of the year. Sound familiar? We've actually had to tell David to slow down. We filed for a second patent covering a laundry list of new inventions, many of which were developed by accident or during the Miami project. And we're diving into the fully integrated building components that will be used to construct Curve Appeal this year right here in Chattanooga. Through each of the moments I've shared with you, we've learned perhaps what every mission is given to teach us. Our backgrounds didn't prepare us for the challenges we faced, but our lack of experience led us to new approaches that the experts had never tried. We broke things, a lot. But sometimes we managed to break the thing that was holding us back. We made the greatest project progress when we turned away from the things that we felt equipped to do and toward the things that we felt called to do. And as much as things have changed for us, we still wander unknowingly into the unfamiliar. We still break things, and we still bite off more than we can chew. But if past is prologue, there's only one way forward for us. We have to say yes.